Hey everybody, it's Mr. Sauce here. Hope you guys are doing all right. I just wanted to make you guys a quick video on the substitution method um, and talk about some of the steps to this method that have been working on over the past few days or so of class. And the substitution method, as we've talked about, is a much more efficient method than the graphing method that we have already covered this module. And the substitution method, let's just start off with an example here. If we had our system, right, a system is a group of two or more equations that work with each other to solve values, right? We want to find the value of x and we want to find the value of y. And those two equations, they work with each other to find out a value for x and a value for y. Okay, the way that they work with each other, right? One of the methods is through the substitution method. Okay, in the steps of the substitution method, I'll just read them off real quick and then we'll apply them into this example. First, we want to solve one of the equations for either variable. You'll notice that as I go through these 4 steps, there's a lot of choice. So you can solve one of the equations. So you choose which equation you want to solve for either variable. So you can choose the variable, either x or y, that you want to solve for. So there's a lot of choice. That's why it's good to show a lot of these examples here. Step 2 is we substitute your solved equation into the second equation that you didn't use. And we'll talk about the meaning behind that in a second. Step 3 is we solve the new equation that we create for the variable that's in the equation. And another name for that is just called isolating, which we've used before. And lastly, step 4 is once we isolate from the variable in step 3, we have our first answer for one of the variables, right? So we plug in that value that we get into either of the original equations. So there's that choice again. So we plug the value that we get into either equation and then solve it out for the remaining variable. Okay, so if we ended up with x equals 3, we plug in the 3 for either x, we solve it out for y. If we end up with y equals 3, we substitute the 3 in for either y and solve for x, right? So it just depends on what we end up getting for our value or our answer. That's where we plug it in. Okay, so if we were to apply this example to these steps here, step number 1 says that we want to have both or one of the equations for either variable solved, right? And you can see that for this example here, right? Both of the equations are actually already isolated. Okay, they begin with y equals 2x plus 8, and then the second one begins with y equals 5x minus 1. So we're off to a really good start. We don't even have to do anything right away for step number 1. Step number 2, though, says to substitute your solved equation into the second equation. Now, when you're given both of the equations already solved for you, like this example, it doesn't matter which value you're going to be plugging in. So what I mean by that is you could plug in that 2x plus 8 for the y, or if you really wanted to, you could plug in that 5x minus 1 for that y on top. All right, so it doesn't matter which way in this case. You could plug in either order. I just stuck with plugging in the 2x plus 8 for that y here in the second equation. Doing so, okay, we still have 5x minus 1, but instead of y on the left, we're going to have 2x plus 8, right? So that's where our two equations will work with each other. So our new equation that we're working with is 2x plus 8 equals 5x minus 1. Okay. Step number 3 says to solve this new equation for the variable. And the way we're going to do that is by combining like terms. So on this side of the equal sign, we can't combine either 2x and plus 8. And then on the other side, we can't combine either the 5x and the or the negative 1. So that means we're going to have to remember how we bring terms across the equal sign. So if we focus on the two green box terms, right? So it's 2x and then 5x. Both of them are like terms because they have the x as their base in common. Right? So if we wanted to combine or bring the 2x over here to the 5x on the right, how could we do that? We do that by subtracting 2x, right? If this was a positive 2x, right, we'd have to end up subtracting that across to the other side. If we would do so, right, 2x and 2x, they cancel out, leaving you with just an 8 equals 5x minus 2x gets us to 3x, and then negative 1 or minus 1 just comes down as part of the equation. Okay, so combining our x variables, right, we have a 3x now on the right instead of a 5x. Next, we want to combine the constant terms, right, the regular numbers, and the way we do that, we need to bring this negative 1 to the other side here. So in order to bring a negative 1 to the other side, we'd have to do addition of 1. Or we'd have to add 1, because that would cancel out the negative 1 on the right, and adding 1 to 8 will get you to a 9. So you're left with, on the right side, just a 3x. So 3x equals 9. Our last step, we have one step, we need to figure out what this x equals. And the way we do that is by doing the opposite operation there. 3x is 3 times x, so we need to divide on both sides. Right, 3 divided by 3 cancels out. 9 divided by 3 on the left here gets you to a 3 as your final answer here for x. All right, so after we plugged in our solved equation, we just have to focus on isolating whatever the variable is. Now, the amount of steps that you have to do that in will depend on the equation. Okay? But sometimes you'll have to focus on distribution. Sometimes you'll just have to focus on this skill of combining like terms. So it just always depends on the equation there at this point. But what we've done is we've found out our first term, right? X equals 3. We know that now as a fact. However, there's an x and then there's a y. So what we have to do is step 4, which tells us that we have to plug in that value that we just got, which was a 3, into either one of the equations and then solve it out. And where we plug it in has to do with what variable we solved for at the bottom. All right, so this was an x equals 3. We have to plug in our equation for the x's here in the original 2 equations. So I'm just going to rewrite the equations here so we can clean it up a little. But we have y equals 2x plus 8, and then we have our second equation, which was y equals 5x minus 1. And as we just mentioned, we need to take that x term and plug it in to either one of these equations for the x in the original equations, right? So 3 was what x equaled. So instead of writing our first equation as 2x plus 8, we could write it as 2 times 3 plus 8. And then likewise for our second equation, and remember, we only have to choose one of them. Choose one of the equations. I just want to show you how we could set up both of them. But instead of 5x minus 1, we'd have 5 times 3 minus 1. So notice how both of the equations stay the same except for the x's, they just change out from the 3 here. If you were to solve both of those equations out, right, if you took 2 times 3, which is 6, 6 plus 8, which is 14. So our first equation will get you to 14, and then 5 times 3, which is 15, and then 1 less than 15 is 14. Right, we'd find out our answer. Our 2 values would be x equals 3 and y equals 14. So that's the idea here with the substitution method. I think we're going to do pretty well with it, but I do want to show you one last example here in just a second. All right, so for our second example, we have 3x plus 5y equals 13. And then the second equation in the system is 2x plus y equals 4. So for this specific example, for step number 1, right, we want to see if one of the equations is already isolated or solved for a variable. And if not, we have to do so. And if we look at both of these equations, neither one of them this time are solved or isolated. Okay, so the y is by itself, but we see on the left side here the 2x is with it. So it's really close in the second equation. So that's probably where I would begin, right? I would notice that that y is already by itself here. And we just got to figure out what we can do with that 2x to bring it to the other side. And if you think of it, right, this is a positive 2x. So in order to bring a positive 2x to the right, we need to subtract it, right? That would cancel out the 2x here on the left, giving you just our isolated variable, which is y, equals, when you subtract the 2x here from the right, there's no other term you can actually subtract it from. So what we do is we just write the negative 2x here as our part of our new equation. And then that plus 4, that positive 4 that was originally there, still stays. So our new equation that we just created from doing step 1 was y equals negative 2x plus 4. And the reason why we need to do that, everybody, is because we need to create an isolated variable. Right? So our y is now 100% isolated here on the left. Because what you're thinking is probably accurate here. So for step number 2, we want to substitute our solved equation that we just got into whatever that second equation was. Okay, so our solved, when we did step number 1, we created this new equation, right? I'll write new here just so we can clarify that this is our new second equation, new number 2. Okay, and this was old number 2 right here. Anyway, what we need to do is we need to take whatever that value equals here in the solved equation and plug it in for the y up here in that first equation here, the second one. So what that looks like, if we were to do so, is we take that negative 2x plus 4, plug it in for the y. We'd end up with the equation of 3x plus 5. Now instead of plus 5y, we have plus 5 and then times this entire equation here. So times negative 2x plus 4. And then equals 13 still sticks as our second side of the equal sign here. So we have 3x plus 5 times negative 2x plus 4 equals 13 is our equation we're working with. And that brings us here to step 3. And step 3 for this one looks a little different now because we have those parentheses. And whenever we see those parentheses, I know we've hammered this down for a couple modules here. But whenever we see those parentheses with a number directly outside of it, there's a specific property that we like to do in order to simplify those parentheses. And that property is called the distributive property. Okay, so the distributive property is basically like double multiplication. So you take that term on the outside, remember, and you multiply it by the first term inside. You write down whatever your answer is, so question mark. And then you take the outside term again, and multiply it by the second term inside, and you get another term. Okay, so let's figure out what our two terms would be if we did the distributive property. So 5 times a negative 2x would be a negative 10x, and then 5 times a positive 4 would get you to a 20. So undoing this entire parenthesis here from distribution, we have negative 10x plus 20. We're going to drop down the 3x here, and the 13 is just our new equation. Okay, one step at a time. And now we take a look and we have to combine the like terms again. However, this time we have two terms that are on the same side of the equal sign, so we can look to take care of those ones right away. And if you see, we have a 3x plus a negative 10x. And when you have the positive and negative sign next to each other, okay, sometimes you don't see that, but sometimes you do. And when you do, the negative sign, when there's different signs, the negative sign will always take charge. So positive and negative is just a negative. So 3x minus 10x will get you to a negative 7x. And then we still have to worry about this 20 here, but we can't combine them right away because there's an equal sign. So that means we have to figure out what we have to do to that 20 to bring it to the right side here. And if we notice it's a positive 20, in order to do the opposite of it, just swing it to the other side, we have to subtract the 20. Okay, so 13 minus 20, the 20 and 20 cancel out, but 13 minus 20 will get you to a negative 7. So our next step and our last step here in our step number 3 would be to figure out how to isolate this x. And that would be to get rid of the negative 7 in front of it, which is being multiplied. So we have to do it by division. We have to cancel it out by division. Negative 7s, they cancel out on the left. They cancel out on the right. Whenever you have the same number on top of the same number, it just equals 1. Right. So after doing all of this work here, right, rearranging the second equation here, this old number 2, to create this new number 2 equation, and then plugging it in, solving it out, we get a 1. Okay. But now we have to figure out what y equals. So the way we do that is by doing step 4, which is plugging in the value we just got into either of the equations and solving. I'm just rewriting the 2 equations here again. Notice how I wrote the new number 2 equation here instead of the original one. What we have to do is look to plug in that 1 that we just got for either of the x's in the systems here. So writing these equations both out, it would look like this, right? Instead of the x here on top, 3 times x, it'll be 3 times 1. Instead of here, negative 2 times x, it'll be negative 2 times 1. All right, if you were to solve both of those equations out, I would choose the second one because you only have to choose one of them, but I would choose the second one here because y is already isolated, right? It would be y equals negative 2 times 1, which is just negative 2. So negative 2 plus 4 would end up getting you a positive 2, giving you your final answer of x equals 1, y equals 2. Now, I hope that video helps you guys out with this method. There was 2 examples there, and there will be more to come. However, this method, once you really master these steps here, these 4 steps on the screen, you can fly through a couple of these problems here. So do your best with these. I hope that this helps, and I will see you guys all in class. Have a good rest of your day today. Take care.